those methods now is in a number of different ways. So one of the additional things that we've been working on recently with a few different clients is how do you take your user interface that you've developed in Shiny and allow the user, yes, to select the parameters they want to run their model in real time, to get their results, and then all the normal stuff that we would build into the apps. So the ability to download an automated report, the ability to download plots and visuals, but then also how can they then to make it as reproducible as possible? How can they then take that all of the settings that they've made in the app and take that and export out a zip file containing the R project with the project file, the model itself, all of the data, all of the tests, all of the R code. And so we've done a couple of projects now with clients where we've done just that. So we have a little button on the UI which basically says download reproducible report, and it downloads that as a zip file. And so then there you can kind of increment from that point. And so the idea is that in the user interface, the users are getting kind of 90% of the way there. They're selecting their features, their parameters, they're running the model, they're getting all the information they need. And for a just key decision maker or a stakeholder, that would be enough. But for the actual modelers themselves, they might want to continue and make small tweaks to the structural assumptions or something in the model. How can they then export something? And so that's exactly what we've done and in this format, and that seems to be working well and is improving the efficiency of kind of model adaptations within companies. Um, yeah, the next kind of really big step and a step that a number of different companies are working on at the moment, and I know kind of everyone's trying to crack this, is how can we take these Shiny apps, these model platforms, and then use those to select a specific country for the model, and then be able to export out a kind of almost submission ready Excel country adaptation model. And so this is something that a number of people are working on at the moment. I don't think anyone's like got it perfect yet. So it's very much something in development, but it's definitely something over the next sort of year or two we're going to be seeing. And given that these country adaptations are very expensive and time consuming, I think that we can see huge gains in efficiency here. So I know a number of companies working on this in different types of ways, which is really nice. And so ultimately, over time, I think we're going to see success there and a lot of learning between companies. I just wanted to share kind of one more slide before I kind of go into the bigger picture stuff, which is commonly one of the concerns we get when we're working in Shiny and when we're deploying these interfaces online is how we can ensure data security and how we can keep data secure and how we can collaborate on things without being concerned about that. So I just wanted to show a quick example of how this can work and how this has worked with some of our clients in the past, using an example fake um, uh, company name, VitaCure. So don't worry, you've not missed out on the newest pharma company around. But essentially, the way this works is we would have our project repository, so our GitHub repository, with only code and some dummy data. And that would be our development app that we work off. And we would work on that and ensure that everything is robust, and we'd provide access to our collaborators at the client company. And so they would be able to access all the code, all the dummy data, and see the app and the platform that we're building them in real time. Then when they're ready, they would take a fork of that repository, it's essentially a copy of that code base, over onto their secure platform. And then they would have their version of that code base, and they would delete the data that or the folder that relates to the dummy data and insert in their real data. And then they have a local version of their app, which they can test locally and can have a production ready app deployed online via, say, POSIX Connect or POSIX Workbench is probably the most common way we've seen it implemented. And so it's this kind of system where we have dummy data on our side as consultants, and then within industry or academia, the actual data and actual, but using the same code base. And this has been really successful. The limitation to it is it does require somebody on the company side or on the academic side to kind of know about how to use this and work with IT. But we've had a lot of success in making this viable over the last few years. So just before I finish up and take some questions, I just wanted to summarize kind of where we are now and where we're going because I've been doing this for a while, as I said, initially shouting into the void, um, and we're definitely seeing a lot more success. So I think pre 2020, there were a lot of kind of academics, very much a kind of an academic exercise in how could we build these models, these script-based models in R. And I don't know if that's a flattering photo to Gianluca Baio and others and Howard and others who've been shouting about this for kind of since sort of 2015, 16, 17. But initially there are a large number of publications kind of coming out saying, we can build this in Shiny, we can build this in R, we can use this R package for flexible spiral analysis, all of those kind of things. And then that gradually filtered through into training. So suddenly, a lot of short courses sprung up on the use of R. A lot of people going to the Darth group. And those of you that know the Darth group and Aline Kniekamp over in the Netherlands, in particular, have been really good at like promoting this and making this accessible, being super friendly, super engaging for groups that wanted to learn. And then increasingly, kind of remotely, we've been running our own short courses, as I've mentioned. And so there was a period where there's just a lot of people building up these skills. And now it feels like we're in the phase where industry has said, yes, we need to adopt this. And I think that's partially driven a little bit by it just being a function of time. So kind of those stages of having a research publication base and then building up a big enough body of people who are trained in this, either from those short courses and now within MSc programs, most are doing a significant component of R, and those people filtering through into industry, into academia, into more senior roles, and understanding the efficiency gains. Um, I think there's some of that that's just happened as time's gone on, but I think also uh, the use of generative AI, LLMs to help kind of people as they're coding has reduced the barrier to people learning to code for the first time. And so that's also increased adoption. And then, as well as that, also the use of kind of LLMs kind of within the workflow and how easy that is with script-based programming languages to call APIs within the model itself or reports itself has also been really useful. Um, and the other thing that's definitely happened is since the pandemic, there's been a kind of wider adoption of real world evidence and kind of these automated living reports because a lot of that was used during the pandemic on case data and infection data. And so there's been a kind of a wider use of just kind of automating stuff out. And finally, in Europe, especially the changes with the JCA and the kind of speed at which things needs to be analysis needs to be done has meant that kind of the JCA is almost the HEOR equivalent of the pandemic, where it's kind of how can we do this stuff faster and meet requirements more quickly. So it really feels like we've gone from kind of an early stage really to now a rapid acceleration in the demand for these platforms and these script-based models. So yeah, just to finish off, if you're interested in learning this stuff, then check out our courses, and we have a free reading list online, which I can share in the chat afterwards, where we basically just outline all of the key publications. If you just wanted to learn this stuff and read and get more information, we kind of categorize it down into different learning kind of background stuff and different types of models that you might want to learn about, and highlighted the kind of tutorial papers that are there with free open source code. So yeah, I'll stop talking and open things up for questions.
That was a really interesting talk, Rob. So if anybody'd like to start with a question, I don't see any in the chat group chat. But, but Rob, may I ask you? I mean, one of the reasons to use R is certain simulations can't be done in Excel, such as discrete event simulation, or not well.
Yeah, definitely. And we're seeing that. So as well as the benefits for even, Markov models or decision trees where you can do a lot of this extra functionality, there are just models that just they the computational burden is so great. And discrete event simulations and micro simulations and agent-based models definitely fall into that category where um, trying to do it in Excel is just a nightmare. And people are running these things over the course of days and waiting for them to run. And it just doesn't make sense. And so anybody coming into the industry who hasn't kind of seen the background of the way that these models have kind of gradually got more complicated, anyone who's coming in from, say, infectious disease modeling world or epidemiology world, like pure epi world, or coming in from other areas like finance, are just looking at these models and going, why are these in Excel? Like this doesn't make any sense, and it's just a legacy thing.
Yeah.
But yeah, so we're definitely seeing more demand for those types of models to answer more nuanced questions, especially around things like the distribution of effects across different individuals in society, which is just far easier to answer with a microsimulation model than it is with a Markov model. So questions like that are super important.
I see a question by Fab. Go ahead, please.
Hey Rob, this was very, very great presentation. Thank you very much. And I agree with you. I've seen a lot of models that has been a legacy in Excel, and they haven't been improved over the years. Are there packages in R or other softwares that they can transfer these models into R, or there's any improvements on that? I know that there is ways to move from C++ to R, and doing some of those transitions, but I'm not sure if there is any for Excel versus R.
So there is a set of software developed by the University of Bristol and Howard Thom to build essentially to convert an Excel model to an R script. That piece of work was undertaken to be able to run the model very, very quickly for value of information analysis and to understand the sensitivity of different parameters. So it's an automated process, so you can upload your Excel model and you can get in return an R script. However, what is returned is not an R model that in the way that we would build it. It's an R model in the way that a computer builds it. So it's just a series of lines of almost unintelligible code. Um, and so it's really, really useful for things like, say you have an Excel model and you want to understand sensitivities, you can just treat it like a black box and change the parameters, run this script, and get a new set of results. It's also really useful if you want to have like a user interface or something, you can build it around this script, but it's not good for like I want to take my Excel model and then I want to convert it to R and then I want to build upon that. That it doesn't really quite work for that yet. Although I suspect there's research going on in that area as well. So yeah, it's a good question though. I think there's a huge number of Excel models that we need to somehow convert to R, and that's an expensive process. So yeah.
So just to shortly comment on that, there have been some initiatives to use AI like ChatGPT to build R-coded models. So that could be an option that could be improved over the coming years to transform Excel-based models to R-based models.
I think that's what we're going to see. Yeah, I think we're going to potentially see that tool that was built by the team at Bristol called Reaver, R triple E V E R, and what I could see is that functionality being extended with generative AI to take the R output from that generates that's not very readable by a human and say to the Gentivier tool, actually now can you convert this to be, in functions and nicely structured, and that would be really useful. So yeah, that'd be good.
And any other questions? Yes, Ankur.
Yes, thanks for this presentation. It's so exciting to see so many people on the call as well. I remember when I started in HEOR in 2005 at a consulting company, we did all of our models in Excel, and that's just the way it was. And so it's really exciting to see all these developments. Now, in academia, I hang out with some like super nerds who actually look down on R, and they say people should, not me. They say we should be using Java, C++, and I wonder, do you think that R is this kind of sweet spot middle ground? Do you think there's something about almost like a reference case? You know how we talk about CEA, that like if the community kind of adopts R, then at least we all have this kind of common language that we're looking at. Or do you think that my super nerdy friends' arguments about speed and perhaps even more transparency are kind of overstated?
Yeah, I think I probably annoy everybody by being kind of in the middle ground of this argument, where I I think generally I'm kind of agnostic to the programming language being used. It doesn't really matter whether it's R. The big shift is from Excel to script-based model. Because once you've made that shift, you can kind of, I mean, especially the way we build models in small unit functions of 30 lines of code, you can call Python from R, you can call, Julia from R. So where you write those 30 lines, which programming language, kind of doesn't matter. The big change is from a spreadsheet where you have lots of cells where you're trying to figure out where everything goes and jump between different tabs, to a set of sequential script-based instructions that a computer can run. I think that's the really big shift. I think where R is kind of superior to the other languages, so I would maybe disagree and push back to your colleagues, is that we just already have some pretty well established R packages for certain tasks. So survival analysis, pretty much everyone's using FlexServe. I don't know if there's an equivalent in Python that's like as respected and trusted. The Shiny package is fantastic to the extent that lots of people who are using Python they're basically redesigning Shiny to work with Python. And a whole host of these kind of packages that have been developed with health economics in mind, in particular, that mean that it's got kind of a head start. And I think that, I guess, trusting and validating these packages takes a lot of time. So once you've already got something like FlexServe that's there and established, it's very hard for another programming language to come along and say, this is a better package, because everyone's using FlexServe. So yeah.
Thanks. Other questions? I have a question on the use of packages. So I'm really curious on your view in terms of you have these kind of packages that do the modeling for you. So things like HeMod and I think HeSim as well for Markov models, and there are also packages for doing microsimulation. And versus building these models in base R code, so you can actually look what these things are doing. So what's your kind of view on these two approaches of building a model?
So personally, I tend to build most of the models as in base R, or using subcomponents of small functions from previous models. So I'm not using a kind of like a model builder package like HeSim or HeMod. But for certain types of models, I could understand why somebody would want to do that. If you had a relatively simple Markov model, I could understand that. There's a really nice presentation from RHDA back in 2023 in York, where somebody goes through, I think Chris Fawcett goes through, where they built a model in R. I can't remember the package, either HeSim or HeMod, and there was some small nuance that the client asked for with the model, which meant that it couldn't quite be tweaked in the way they wanted. So they kind of ended up scrapping it and going back to rebuilding. And sorry for Chris if I've paraphrased that wrong, but that's why we've just stuck to building them in ourselves, but calling on small functions, small units from different sources. And so we might use the discount function from Hmod or something, or we might use a equal value life year function from one of our internal packages. But the model itself, the core kind of structure, we're building from scratch each time. Yeah.
To keep maximum flexibility and
yeah, exactly. So yeah, that's exactly it. And we've I've got a couple of presentations and the paper that we wrote on building models as packages kind of outlines the long-term view that if we can make enough work open source, especially if we can make them open source as our packages, so not a package to do everything, a package specific for that model with the functions for that model, we can then kind of use the functions from different models. So you'd say like, I'm going to use the same discount function as this model used back in 2022. And if that's already been reviewed and validated and approved, everyone's happy that that function's good. And so over time, you can kind of just utilizing units from different models rather than having a kind of single model builder. That's kind of the approach that I've gone down. And thanks to Whale for showing that paper.
Yeah, thanks. Any other questions?
Normally, I get at least one person who tells me that some new update to Excel means that it's better. So yeah, so I'm pleased that yeah, we got everybody on board.
Very good. We have a question.
Well, yes, I'm gonna ask one more question. So Rob, I've been in industry for quite some time, and what I've learned here is, I'm the owner of a very large micro simulation model in Python. It's like 20,000 lines of code. The only person that understands in the company is me. And whenever they need an analysis, they reach out to me to do the analysis. And well, it was frustrating because the model takes a long time. We're talking about maybe 200 different scenarios and do a PSA. It may take a month. So we decided to build a small Excel model for them so that they can use. And it seems that, out of everything that we do at our company, that is the most useful thing for them. The Excel file that they can run it. The marketing team can run it. The market access team can run it. The salesperson can run it. Now, I think there is a missing piece, and maybe when we talk about the shiny portion of what you've done, it is that the end user now can be anyone. It doesn't need to be an health economist. It doesn't need to be somebody with those backgrounds. More or less, it's somebody with just the same Excel experience, right? Once we have this model developed and it's ready to use, we don't need any other anything that needs more of experience or more of education. You can use it. So I think this is important, and I wish you can talk about this in the future when you're presenting this, because again, in industry, we do not see too many people with the background in health economics or with the backgrounds in R or any other programming languages.
Completely agree. And the shiny component has been the real game changer at engaging stakeholders. And just on your last point, we really struggle to hire because just that niche set of combination of skills is still so rare. It's definitely growing, as I said, with people joining the courses, it is growing, but it is a really rare set of skills to kind of understand kind of how all this fits together, the health economics, the programming, and the user interface design, and like how a user can flow through that. Yeah, I think the more people that kind of learn to manage that process and work with teams to integrate that, the better. Yeah.
There's one more question in the chat, and I see Raymond, you also had a question, and I like to use the last like 2-3 minutes to just say something about our special interest group. Could you, Robert, maybe take the question from the chats from Jose Paredes? And the question is, Do you think as a transition way by now to use Excel to produce simulations of non-complex models, than to use them as inputs in R? Okay, I'm not fully sure if I understand the question. Maybe Jose can highlight the question, or maybe you catch it and can answer it.
I'm not sure. I think so. Yeah, I'm not sure I understand the question. I think
It seems like,
yeah.
if to paraphrase Jose, sorry, is it using Excel? Just forget about the transition, by the way. Excel to produce simulations of non-complex models, then use them as inputs in R. Kind of the same thing I think you were talking about, Rob, in terms of R Shiny. So to use Excel, I believe I'm understanding this right, Jose, is again, this user-friendly front end, and what Vahab had mentioned also, for non-complex models. And a lot of models really are not that complex. People might think they are, oh, it's my sophisticated model, but there's a lot that's really not so sophisticated. I don't know what you think about that.
Yeah, absolutely. So we could have a Excel front end rather than Shiny. And I've seen that in a few different cases. I've seen it both ways. I've seen it an Excel front end running either Python or R in the back end, or a R Shiny app, which then sends data and information to a Excel to run the Excel and return results. So I've seen both ways. In both cases, I'm always just a little bit bemused because this is quite a complicated thing to set up and requires, like beyond the scope of most health economists and kind of more into computer science
You're not going to
realms.
call all kinds of scripts
Yeah,
because you're using this user-friendly front end.
yeah.
It maybe defeats the purpose.
Yeah, so I've tended against it, but I know it's served a purpose for people, and people have gone for it. But I personally wouldn't recommend it. I just think, especially if you're going to build a model in R, Shiny is so easy to integrate as a front end. And if you're going to build your model in Excel, then you already have Excel for the front end. So yeah.
Hey, thanks a lot. I'm just going to share the screen here with our website, and then I'll leave it up to Raymond to end the meeting. So I just wanted to highlight here that we have our next meeting is a brainstorm session on licensing, versioning, and documentation, and code reviewing and validation, and that pretty much also aligns with these kind of things in terms of using R to make it more transparent, and how can you code reviewing of that kind of stuff. And if you want to make your model open source available, which is the core issue of our special interest group, how can you make sure that you have the right license, and how can you versioning and documentation of your model. I also like to make a statement here, inviting you all to join the SMDM, the medical decision making group, and feel free to sign up for the brainstorm session. And if you want to know more about us, you can go to our website. It's opensourcemodelgroup.wordpress.com,